A square pyramid, base side 30 mm, axis length 50 mm is resting on HP with one of its triangular face vertical. Draw its projection. Always the initial position is very crucial. So we have problem where the solid is resting on HP. So we start the top view first. This is a square pyramid. So we have drawn a square with the diagonals crossed with dark lines. Here is triangular face. So whenever we have the triangular face on the ground, triangular face vertical, then we need to follow the side position. What do you mean by side position? In side position, we need to give any one side here AD, any one side perpendicular to XY. Here AD is perpendicular to XY, BC is perpendicular to XY. So therefore we get BC together in one place and AD together in another place, so that when we combine any one of these 2 points with O dash, you would be able to get a triangular face. So here is OBC is one triangular face and OAD is another triangular face. So we take any one of these 2 triangular faces, and in the next stage we are going to make it vertical. So it's very clear. Now we have put the base completely on the ground in this particular position, mainly because we want the triangular face to be vertical. For every projection of solid problem, the initial position is very crucial. If the initial position is wrong, everything goes wrong. Had it been with corners on the extreme, let us say A on the extreme and B on the extreme, so we have A at one place and O at the other place. When we join, we will get only slant edge. We won't be able to get triangular face. Now it is because the flats are perpendicular to XY. We have AD perpendicular to XY, BC perpendicular to XY. We are able to get A dash D dash at one place and B dash C dash at one place, so that O dash B dash as a single line possible, O dash A dash D dash in a single line possible. So what we do, we make any one of this triangular face vertical. Let's take the O dash B dash C dash as the triangular face. We make the point B1 dash, then C1 dash. Now we can reproduce the same isosceles triangle in such a way that one triangular face strictly vertical. So now this is our O1 dash, O1 dash. So therefore here is O1 dash, B1 dash, C1 dash is a strict vertical line. So this is the answer. So we join this. Now with the help of this, we have to reproduce the same isosceles triangle with the help of this line. So what we do, we follow this. We just make this a center and this one as radius. We just make an arc. And upon this arc, when we take this base side, the distance across the flat, and cut it on here, you will be able to get the new required position. So this is our final A1 dash and D1 dash. So now we can join this and get the new position. The new position is that any one triangular face should be strictly vertical. A plane is perpendicular, then the projection should be a line. If a plane is perpendicular, then the projection should be strictly a line. Here also OBC is now just a line only. So therefore we can say the triangle OBC is perpendicular, or in other words it is vertical. So now that we introduce the axis, so axis line can be drawn through this point. So this is the final front view for a square pyramid with one of its triangular face vertical, and it is resting on the HP as well. So it is resting on the HP with one of its base side BC on HP. This can be read in a different way, in another way, as such BC on HP such that OBC is perpendicular to both HP and VP. BC is a line in front view, it is still a line in top view as well. So therefore we can rewrite the problem as square pyramid, base side 30 mm, axis length 50 mm is resting on HP with one of its base side such that the triangular face OBC containing the base edge BC is perpendicular to both HP and VP. The triangular face containing the base edge containing the base edge is perpendicular to both HP and VP. Now we complete the diagram. We can just project this. We have got only two lines to project. This is the first line, which has got 3 points, and you have another line has got 2 points. So therefore that's all for the vertical projection. So we have 3 lines in the top view. We can project that also. This first line, then we have the line for the vertex, the second line for the vertex, that's the second line. Then we have the last line. More or less the answer lies within this square itself. This is within these 4 points. So therefore we have A vertical and A horizontal, we get A1. B horizontal and B vertical, we get B1. C vertical and C horizontal, we get C1. D vertical and D horizontal, we get D1. O vertical and O horizontal gives O1. To find the visibility, what we do, we assume one arrow mark pointing downward. This is arrow mark pointing downward, and we identify the extreme corners. Here is the left extreme corner. We introduce one horizontal line through this extreme corner. We introduce one horizontal line. Then the right extreme corner is this. We introduce another horizontal line. Whatever within this region is visible. So therefore we have OD above these two lines, and OA. These two lines are visible. So here is OD, we make it dark. Before that we can have the outer edges. we can just draw the skeleton. The skeleton for a square pyramid goes like this. We start with A to B, B to C, C to D, D to A. The common point is O. So OA, OB, OC, OD. This is the skeleton. So therefore we have here AB, outer edge. AB is the outer edge. Outer edges are A. So first we connect the outer edge AB, then BC is again outer edge, BC is outer edge, then CD is also outer edge, CD outer edge, then AD, DA. So we have this. Next we have OA. OA is dark, so therefore we put dark line. OA is dark because we have two horizontals, one horizontal from each extreme. This is one horizontal and another extreme is here. So OA is above these two, so therefore OA is dark. OA is dark. Similarly, we can have OD. OA is dark. OA is dark. We have OD also. So OD is also dark. So we have the final answer. So here is AB, BC, CD, AD. Then OA, OB is outer edge, OC is again outer edge, OD is dark. So the given problem is square pyramid, base side 30 mm, axis 50 mm is resting on HP with one of its triangular face vertical. So here the triangular face is OBC, vertical. So it is a line in the top view, OBC. In other words, we have the pyramid resting on HP with one of its base side, that means 2 points alone on XY line. So therefore, at the same time, the triangular face containing this base side, that is OBC containing this base side, O dash, B dash, C dash, and OBC is perpendicular to both HP and BP. Here O dash, O1 dash, B1 dash, C1 dash is a line. O1, B1, C1 is also a line. If a plane is perpendicular, naturally its projection should be a line. If a plane is perpendicular to BP, its front view is a line. If a plane is perpendicular to HP, its top view is a line. If a plane is perpendicular to both HP and BP, both front view and top view are just lines only.